Brady Bunch, the Duke Cranial Neurosurgeon team. I'm Ashley Knight, Chemistry training in Biomaterials.
And Marl Sultani, Bioinstrumentation.
I'm Christopher Myrick, focusing on biomechanics.
And I'm Matthew Yannick, in biomechanics.
Through observations and interviews, we established that current dural closure methods are very time-intensive, and despite advances in neurosurgical techniques, the incidence of CSF leaks remains high.
Based on the problem we identified, here is a brief video showing you the current dural closure method. Following cranial surgeries, the dura mater is too short to fully close the incision site. Therefore, a graft is used to ensure complete coverage. When closing the incision site, surgeons generally prefer to use a running suture to seal the dura and the graft together. A running suture helps to prevent CSF leaks. However, this method can take between 30 to 45 minutes. Once the suture is complete, surgeons frequently use a hydrogel sealant or a fibrin glue as an adjunct to the suture. Our goal is to reduce surgical time without compromising the watertightness of the closure.
Let's consider Becky, a 24-year-old woman who went in for a standard craniotomy procedure. She was hoping to have her symptoms relieved, but instead, she came home with different symptoms. She ended up having CSF leakage, which resulted in posture-related headaches. Luckily, this was caught early, and she was able to avoid more serious side effects like meningitis and even death. Becky's part of the 33% of all craniotomy cases who end up having CSF leakage post-surgery.
All right, let's look at some numbers. So a 2-year-long study at the University Medical Center in the Netherlands examined the average cost of over 400 cranial neurosurgeries. It was found that the average cost difference between procedures with CSF leaks and procedures without CSF leaks was about $28,000 per patient. It was also found that the total extra annual cost to the hospital was about $988,000. That is a huge number, and we plan on significantly reducing that.
Our original design concepts include a photocurable glue, a handheld suturing device, and a circular stapler. We decided to proceed with the stapler design with some modifications. Our first concept involved the use of rotating clamps, which would grasp the dura and the graft and bring them together. The second design was inspired by the endoscopic staplers used in GI surgeries. Due to disadvantages with each of these designs, we decided to move on to a third concept.
This led us to the Duo Stapler 3.0. The design was inspired by a pair of long-nose locking pliers we found in our senior design lab. We decided to utilize the closure mechanism of the pliers that was powered by the compound pivots and incorporate a stapling mechanism similar to that of a regular paper stapler. On the right-hand side of the screen, you can see the prototype that we developed, and on the left, you can see the concept and the design of what we envision our commercial product would look like.
To help you visualize how our stapler will be used in surgery, we made this short clip starring our very own future neurosurgeon, Marl Sultani. As you can see, the assisting surgeon will avert and approximate the dura and the graft. This will allow the surgeon to quickly and easily staple them together without the risk of damaging brain tissue. Our stapler allows for the deployment of staples in either the horizontal or diagonal orientation.
To test the water tightness of the dural stapler, we set up an experiment where we used a tube with a known diameter and filled it up with water at varying heights to produce different pressures with a dural substitute material. Unfortunately, since we had to use paper staples and a nylon material to represent the graft, our device failed to provide a complete watertight seal.
Our final concept comes with 3 main strengths. The first is that it has a mechanical advantage due to the compound joint mechanism. The second is that it's simple and efficient. It allows the surgeon to effortlessly perform the dural closure procedure. And the third is that it allows the surgeon to get into close proximity of the operating site.
The future of this project would involve the development of a line of new surgical staples that are specific to dural closure. The staples would be biodegradable and Z-shaped, as you can see in the picture, and they would cause minimal invasion to avoid the introduction of secondary sources of CSF leaks. Also, hopefully, we plan on graduating soon.
I'd like to thank Dr. Ladd, Dr. Sampson, Dr. DeMayo, Steve Callender, and Jimmy. We'd also like to thank the BME class and all of you for being here today.